Okay, back to polynomials. Again, let's look at the general form of the polynomial, the expression here given by p sub n of x. It equals a sub n x to the n plus a sub n minus 1 x to the n minus 1, and then continuing on in the same pattern, and then the end terms here, a sub 1 times x plus a sub 0. The term a sub 0 here is a constant term. Okay, so now let's look at what the effect that this constant term can have on the properties of the equation. If we were to plot the equation, it would start to become clear. But looking at the equation right here, we see the only time when this equation actually passes through the origin. So if we're looking at a plot of the function, here's the x-axis here. Okay, so here's the x-axis right here, and then this is we're plotting p sub n on this axis, sometimes referred to as the y-axis. The only time we get that this plot is going to go through the origin is when a sub n, or I'm sorry, a sub 0 is equal to 0. Otherwise, you see that looking at this equation right here, whenever we set the value of x equal to 0, so this term becomes 0, this term becomes 0, and any term in the equation that is multiplied by some power of x, that term drops out. So whenever x is equal to 0, we see that the value of the polynomial becomes p sub n of x equal to a0, right? Because that's the only term left here after all the other terms go to 0. So unless a0 is itself 0, p sub n doesn't pass through 0 right here when x is equal to 0. So that's a pretty interesting result right there. So when we look at the general form of the polynomial, we can tell immediately if it's going to pass through the origin by looking to see if there's a constant, non-zero constant term, a sub 0. Okay, now there are a lot more interesting properties, and I'll be talking about some of these later. But let's look at some plots of this characteristic right in here. So I pull up my graphing calculator again. So here we are. Here's a graphing calculator. So let's look at some plots of the polynomial. Let's look at um, x to the x to the fourth minus 3x cubed plus x squared. Okay, so here's an example plot, and let's see, by what I just said, the plot of this function should go through the origin. And indeed, it does. Look right here, and it's going through the origin. The function does a lot of things, but it does go through the origin. Now, if we take that same function, and I, for example, say minus 2 on here, then what happens to the plot? Well, it doesn't go through the origin anymore, but it drops down here to the negative 2. That which, if you plug in x equals 0 into the equation right up here, you'll see x equals 0 means that y is equal to negative 2 at x equals 0. So that's what we got. And then, of course, I could put in plus 5, and it should go through. You can't even see it here. Let me try to pull it down. It's still out of bounds. Make it a smaller number. Let's say plus 1. Okay, so here you see that, in fact, it crosses x equals 0 at y equal to plus 1. Let me do one more example. Let me make this x cubed, make this x squared, make this plus 2, and here we have a plus 1. So where do you think that's going to go through what value of y when x equals 0? And we see that it in fact goes through at x equals 0, goes through y equal 1. So that gives you some idea of the impact that the constant value in the equation has. Now, of course, on this equation, if I set that constant value equal to 0, boom, you see it goes right through x equals 0, y equals 0. It goes through the origin right there. Okay, more later.